Hi everybody. Um, Today what I'm going to do is I'm going to talk about our LTspice 4 tutorial, and it's just about the introduction how to use the program, and everybody know that you can download from Google, just like you can just type you know exactly how to look for LTspice. So LTspice 4 is freeware and download. Okay, so I assume that it's not so difficult for you to install LTspice on your computer. So what I'm going to start is just I'm going to talk a very simple circuit. Look at this one. I have only one DC supply voltage, and then I have R1 and R2 in series with the DC supply voltage, and R1 is equal to 10 ohms and R2 is 20 ohms, and of course you need the ground. Now let's take a look at the LTspice 4. Okay, this is the window that's gonna pop up when you just start the program, and you can see many icons around here, and it's actually not enabled yet. So what you have to do is you have to go to file, and then you go to our new schematic. So you're ready to draw your circuit, and you can see that icons around here they are enabled. You take a look at this one. Start from a wire. That means you want to connect your components together, and this one is ground, and this one used for reference or for the node reference, and this one resistor, capacitor, inductors, diode, and components. This one you want to move your components around when you already draw the circuit, and this one you drag your components around, and also you have rotate, you have a mirror. Okay, as I mentioned, we're going to draw the circuit. So let's start together. You can use either the main menu or edit, and use the sub-menu, resistor, capacitor, inductor, whatever you're looking for. So let's start with the DC supply voltage. I go to component. You can see that there are many components around here. You have comparators, you have transistor here, NPN, you have a PNP transistor, but what you be looking for is the voltage. So just hit OK, and then you can move this one around. And if you see just right here, if you not place your components yet, you can just type Ctrl R to rotate. As for example, Ctrl R, you can rotate the component around, and then also Ctrl E. This means to mirror your component. So you E, okay. Or you can use this one to rotate, and then you just left click of your mouse to place your component, and then right click to stop. And we are looking for DC supply voltage to be 30 volt. So I right click, and you just type it in 30 volts. You click OK, and you also look for resistor. Now you want to rotate, right? So you control R, and then you left click to place your component. You right click to stop placing your component, and you also need one more resistor. So you left click and right click to stop. Now you want to set this one to be what, 10 ohms, right? Click OK. You go to R2, right click, you type in 20 ohms. Let's click OK. And you also need ground for your circuit. The last step you want to do is to connect components together. So you go to the blue rectangle, left click to start, do the wiring. Oops. Okay, I'll start over again. And this one you can, undo. Oops. So I need grounded. Okay, let's start do the wiring again. Left click again to change the direction, and then left click to stop, and then left click to start again, left click to change the direction, and left click. Okay, and okay, you already have completed circuit as you're looking for. Now the next step is that you know exactly that this is the R1 and R2 in the series, and the total resistance is going to be what, 30, right? So you have the current flowing through the circuit is going to be what, 30 divided by 30, so you expect 1 amp, right? The next step you need to do is that before you go to simulate and run, you need to go to setup. So you go to edit, LTspice analysis, and take a look at this one here. What actually you're looking for is the DC operating point. That means this one, after you do simulation, it will show you a detail of your voltage and your current. For transient, this is the perform a nonlinear time domain simulation. This means you want to see your either your output signal in the time domain, and for AC analysis, this is compute the small signal AC behavior of the circuit linearized about its DC operating point. This means, for example, you can say that you can want to do the frequency response. For example, for the gain of your low pass filter, band pass filter, or high pass filter. And for the sweep, you want to sweep your supply voltage, and then you can see your plot. And noise, perform a stochastic noise analysis of the circuit linearized about its DC operating point. DC transfer, find the DC small signal transfer function. You can play around with this one. Okay, but at this point, I'm just want to show you how to do the simulation of the very simple circuit. This one, you click OK. You click on your left mouse to place your operating point. And now you're ready to do the simulation. You go to menu simulate, and then you go to run, and it will take for a while, and then the LTspice will give you information. You take a look at this one. So this is apply voltage V1, and this the node N001 is represent at this point, and the node N002 is represent the voltage at this point. So the voltage at this point compared to the ground become 20 volt. That means the voltage across your R2 resistor is going to be 20 volt, and all the current is just be 1 ohms. But why it's become negative and positive, I will get back to this one later. Okay, but you take a look at this one, the node N001 compared to the ground is 30 volts, and you set up. Okay, let's analyze, why the current. Let's see, IR2, that means the current flowing through resistor R2 is 1, but IR1, or the current flowing through R1, is become negative 1. I think that's because you apply KCL at this point. The current flowing out this point, and the current flowing at this point has to be equal, right? That's KCL. So when the current flowing out from this point become 1, which is the IR2, has to be equal to the current flowing in this point, or the current of IR1. So when the current flowing into this point has to be negative, because we already set up the direction of the current flowing out of this point to be positive 1. Okay, so that's how you use the LTspice for to do the simulation, the same as you use the PSpice. You have like the voltage across R2 to be 20 volt compared to the ground, and you have the current flowing through the circuit become 1 amp, and the current here, the voltage, you set up V2 supply voltage, that's 30 volt. That's the LTspice 4. Now if you want to get the plot, in the case if I want to see how the current change when your supply voltage varies, let's say from 0 to 30, you want to see the plot. So what you can do is that you go to edit, and then you go to spice analysis, and you want to sweep V1. So I go to DC sweep. I want to start from 0, okay, and then I want to stop at, let's say 50 for increment. Let's set it 1, and you need to put it in the name of the first source to sweep. I have V1 as the DC supply voltage, so I type in V1. You click OK, and you also place the box, left click to place, and give you the information about what you are going to do. So this one is, you want to do DC sweep of V1, start from 0 and finish at 50, and the increment is 1. Okay, now you're ready to get the plot. You go to simulate, you go to run, and that will give you the plot. It will come up soon. Okay, now you can see the plot, and you go to the plot setting. You see that this is your x-axis is the DC sweep of V1, right? Start from 0 to 54, and then you go to plot setting to add threads, or you simply go to this icon, pick visible traces. You want to plot the current, right? So it can be either IR1 or IR2. Let's pick up IR2. You hit OK. So this is your plot of IR2 and DC power supply V1. And what we just did is what we have the voltage is 30 volt, right? And you have the current is 1 amp. That's how you know this is the way I click to IR2. I just want to get icon, cursor. You can move left right arrow to see. So this is my horizontal. That means your DC power supply is 30 volt and your vertical is just 1 amp. So that's the current flowing through IR2, or the current flowing through the circuit. Okay, so that's about how to get a plot from a very simple circuit that I showed to you. So if I have something coming up, I'll show you more. Okay, thank you. Bye.